Hello everyone, welcome for this lecture. Today we are going to discuss the numericals on discrete time signals. Okay, so those convolution we supposed to find out. Let's take a first numerical, that is find y of n, which is equal to x of n convolution with h of n, where x of n is this signal. Okay, x of n is equal to u of n minus 3. They have given in the form of equation, and h of n they have given in the form of signal. Okay, that is the signal. At 0 you have 3, at minus 1 you have 1 magnitude, at 1 you have 2 magnitude, at 2 you have minus 1 magnitude, at 3 you have 1 magnitude, and x of n is a signal in the form of equation. So we have to find out u of n minus u of n minus 3. Okay, so first we have to get both the equations, that is x of n and h of n in the form of signal, and then we have to keep any one as a constant and other one has to be shifted and reversed. Okay, method remains the same. Okay, method remains the same as that of your continuous time signal. Here only difference is there we used to integrate it, a formula, that is y of t is equal to integration of minus infinity to plus infinity x of n into x of tau into h of t minus tau. Okay, but in this case we are going to take a formula as y of n represent your discrete. Okay, y of n equal to summation of k is equal to minus infinity to plus infinity x of k into h of n minus k. Only formula is this. Here there is no integration. Here it will be summation. Okay, let's get x of n, h of n they have given already in the form of signal. Let's get x of n. They have given u of n minus u of n minus 1. Let's draw what is the u of n. This is your u of n, right, from 0 to infinity, right? So you have 1 magnitude up to infinity, right, which will have a continuous signal, right? And then next we have minus u of n minus 3, that is minus u of n minus 3. As I told you, minus sign, okay, take it in negative side itself. Okay, while taking magnitude itself you take a negative, that is minus 1, this also minus 1, this also minus 1 magnitude. It continues up to infinity, right? Thing is u of n minus 3. N minus 3 means n starts from plus 3. Okay, that 3 means the signal starts from plus 3. Its magnitude is minus 1, which is your minus u of n minus 3. Okay, then simplify, that is add both, that is u of n plus minus u of n minus 3, this signal. So addition of these two, this plus this, gives us at 0 1, at 1 also 1, at 2 1, at 3 0, because it is plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. So these values will be remains zeros. Only signal we get x of n as, so this 3 signals at 0 1 2 with a magnitude 1. Okay, so let's get what we have to calculate is y of n, which is equal to x of n convolution with h of n, is nothing but summation of k is equal to minus infinity to plus infinity x of k h of n minus k. Okay, so any one signal has to be interchanged. Here you have x of n as well as h of n. Which signal you would like to interchange, that you have to check. Let's see what are those signals. This is your x of n and this is your h of n. Now we have to decide which signal has to be taken reversed, because while taking this summation any one can be interchanged, not a problem. Right, now to take which signal has to be reversed, let's prefer to take this because it is a simple one. You can take a reverse of it and you can shift it. That is x of n signal is this, x of n minus k signal will be, okay, that is nothing but reverse, means take a mirror image of this, will be at 0 1 mirror image, at minus 1 it will be 1, and at minus 2 will be 1. So at 0 I can take this as 0 point as n. Suppose if it was 1, then we would have taken minus 1, then we would have taken n minus 1. Now it is 0, n plus 0, or so simply you can mention n. This is your x of n minus k signal. Okay, so let's shift. We have already shifted this x of n signal. So we have got x of n minus k, that is at minus 2, minus 1 and 0. So this 0 point I will be naming it as n on the k signal. Here k is nothing but a time only. Okay, of a discrete, therefore we have shown it in as a n. Okay, now let's take which will be constant now. H of n will be remains constant. Keep this constant and take this signal. Keep this constant, take this signal and verify. You can take as a n point. We'll be start saying key n point. Okay, n point, and its address name will be n minus 2. Okay, this name of this entire signal will be starting. I'll be taking n, and the end point of this one will be n minus 2, because we are start moving this signal. Hold this point and start moving from this to this end. Okay, so we have to check how much it is going to overlap. Let's take first case. N we have, okay, x of n signal we have, right, at n. Okay, here we have, let's say n is less than minus 1 on the h of n signal. This is your h of n signal. So here it is 0, okay, on that line, and 0 minus 1. You can place this signal on this line only. Okay, you have to check how much signal is overlapping on this signal, h of n signal. Let's say n is less than minus 1. Minus 1 is here. Our n should be, where is n? N is this signal. Okay, this is n signal, right? This point. When you are taking this point, obviously this points comes along with that entire signal. So n is, we are placing below this or before that minus 1. Okay, here 3 signals. This is nothing but your x of n minus k. When you place this, are they able to multiply? This signal is 0 and this signal is present, gives us 0. This signal from minus 1 it is present, from minus 1 this signal is 0. So it will be 0 only. Or you can say how much signal is overlapping on this. Okay, you are placing the signal on below minus 1. I can say it is at minus 2. Okay, means less than minus 1. So now there is no overlapping between those two signals. So we can take y1 of n will be equal to 0. Similarly, second case will be taking. Only thing is, this is a definite signal. Okay, both signals are definite one. This is also definite and this is also definite. We know the end point, starting point and the end point. We know the starting point and end point of second signal also. So we may get more cases. If we have a that is continuous infinite signals, then we may get 2 or 3 signal cases. So here we may get more cases. Okay, let's take a second case, that is n is equal to minus 1. When you take n is equal to minus 1, means we are placing, this is h of n, it remains same, right? At minus 1 you have a signal 0, 1, 2, 3. Now we are placing our signal, that is x of n minus k signal, at minus 1. How many signals are able to overlap on this? Is one signal, that is its magnitude is also 1 and its magnitude is also 1. 1 into 1 is 1. Only one signal is overlapping, right? That's value will be 1. y2 of n equal to 1. Okay. Third case, when n equal to, we have to move bit more, that is n equal to 0. When you say n equal to 0, place this on n, right? N as at 0. So how many signals are overlapping? This signal and this signal. So what you have to do is, let's take those two values. Let's take those two values. First signal, which is this? It is. That is magnitude only we have to take. 1 into 1. Both the magnitude is 1, 1. Plus this signal and this signal are overlapping. Plus its magnitude is 3 into its magnitude is 1. So 1 into 1, 1. 3 into 1 is 3. So 1 plus 3 is 4. Y3 of n, that is when n is equal to 0, you have got y as 4. Okay. So similarly, let's place n is equal to 1. Now earlier case n was equal to 0, at n equal to 0. Now we are placing that n equal to at 1. So if we are placing this is 0, at 1 if we are placing, how many signals are overlapping? See, this signal is also overlapping. Means if we are placing this signal on this, that is like this, magnitude 1, 1, 1. Okay, when you have a magnitude 1, 1, 1, how many signals are overlapping with each other? 3 signals. So let's write all 3 signals. 1 into 1, both the signals are of same. Second signal is 3 into 1. Okay, second signal is 2 into 1. So if you simplify, you get y4 of n equal to 6. Okay, similarly, change it to n equal to 2. That is fifth case, when let's place this n is equal to 2. We can place at n equal to 2. Here also you can place, or I will be placing on this with a magnitude 1, 1, and 1 magnitude. How many signals are overlapped? 3 signals. First one is this. Okay. Second one is this. Third one is this. Let's multiply each. 3 into 1, 2 into 1, and 1 into minus 1. The signal is, that signal is minus 1. Therefore, 3 into 1, 2 into 1 plus minus 1 into 1. Okay. So therefore, you get, simplify this, you get y5 of 4 equal to 4. Sorry, y5 of n equal to 4. Okay. Similarly, let's place n is equal to 3. Means we are increasing one number, n equal to 2, and then now n equal to 4. Okay. When n equal to 3, now let's place this is 0, 1, 2, 3. Let's place this n signal, that was x of n minus k signal, on 3 of this signal. So let's place its magnitude is also 1, and which signal we are placing is also has a magnitude of plus 1. And at 2 we have one signal which magnitude is 1, and third one is this. So these 3 signals are overlapping. First signal is this, second signal is this, third signal is this. First signal is 2 into 1. Okay, 2 into 1 plus second signal is 1 into minus 1, because this signal has a magnitude of minus 1, and which signal is overlapping is plus 1. So minus 1 into 1, and third signal is both the magnitudes are plus 1. So value will be simplified. You get y6 of n equal to 2. Okay. Next, let's increase n is equal to 4. When you place n is equal to 4, okay, so this signal will be at 4. Earlier there is no signal on this line, right? There is no signal on that line. Then if you are placing at 4, it is a 4. On 4, one signal, this signal, and this signal. So how many signals are overlapped? This signal and this signal. Here there is no signal, so this will not be considered, like 0 only. Okay, that is observed here. Okay, so fourth, 3 and it is 2. Overlap on this. There is no signal in the first signal, and second signal is there, third signal is there, right? Only these 2 signals are overlapped. That is minus 1 to n, 1 into 1, and 1 into 1 signal. Plus first signal was 0, second signal which was overlapping was 1. So simplify it, you get y7 of n will be 0. Next, let's change it, n is equal to 5. Now place where n is equal to 5. So it is at 5, 4, 3. So how many signals are overlapped? If you are placing on this 5, 4, 3. How many signals are overlapped? Only one signal is overlapped, that is both the magnitude are 1, 1. So 1 into 1 is 1. Now let's change n is equal to 6. That is, let's place n is equal to 6. So if you are placing here, how many signals are overlapped? Nothing. So yn of 0 is equal to 0. Sorry, y9 of n equal to 0. So now, so overall, what you have to do is at n is, okay, when n is less than minus 1, y of n was 0. When it was equal to minus 1, it was 1. At 0, 4. At 1, means when n is equal to 1, you have got 6, y as a 6. And when 2, y was 4, 3, 2, 4 zeros, 5, 1. And when n is equal to at 6, then y of n was 0. So these values you substitute here, means you put in the form of graph. That is when minus 1, okay, when minus less than minus 1, means I can take it as a minus 2. That time it was 0. Next, at minus 1, its value was 1. Okay, at 0, its value was 4. And at 1, it magnitude, that was y of n was 6. Okay, highest magnitude. And at 2, it was 4. And at 3, okay, 3, it was 2. And then at 4, it was 0. At 5, it was 1. At 6, it was 0. This is your y of n once you have done convolution. Okay, so now we can take another numerical, okay, which is they have said that evaluate the discrete time convolution sum given below. That is y of n equal to u of n convolution with u of n minus 3. Okay, so when they have given these signals, they have given in the form of equation only. As we know, y of n equal to x of n convolution with h of n. Now x of n is u of n, h of n is u of n minus 3. Now let's get signal x of n equal to u of n. We know this u of n is, okay, so it's starting from 0 to infinite signal, that is 1 magnitude of 1 1 1 1 1. Okay, and next h of n, that is u of n minus 3. N minus 3 means n equal to 3. So signal starts from 3, which has positive 1 magnitude and up to infinity. Okay, so these two signals we got. Now it's our choice to take any one signal reverse, and we have to check. Remember, these two, both the signals are not finite one. Those two are infinite because started from 0 to infinity, 0 to up to infinity signal you are getting. Okay, when you have such cases, you will get only 2 or 3 cases maximum. Okay, so now which signal we have to interchange? Let's take this signal because it is bit simple signal, that is u of n. If you reverse and shift this signal, you get this, that is x of n minus k. U of n, that is x of n, we know. Take its mirror image. It will be starting from 0 to minus 1, minus 2, minus 3, minus 4, but magnitude will be 1. Okay, so once you have changed, okay, once you have changed this, let's say this point as n point. Okay, let's take this as a n point, and then this n point we have to shift, goes on shifting on the h of n signal. Okay, we have to say this n point is less than or greater than whatever the value based on your h of n signal. Okay, let's take the cases of 1, 2, 3. Observe here, this you have to remember the signal. Okay, where your signal is, how your signal is moving, and then you have to take this point. Whenever we say less than 0, less than n should be less than 0 means on this signal which is a constant, okay, which was a constant is, you have to take this as x h of k, I'm sorry, okay, this is h of k and this is on the k line, okay. So now n point you have to place less than 0. If you are placing this less than 0, any signals are overlapping with this black with blue? No. So then first case will be equal to 0. And then if you are placing n is greater than 0, less than 3, that is between this, if you are placing, then any signal is overlapping? No. That time also it is equal to 0. Then what we can do is, signal condition is below this 0 is also 0, greater than 0 and less than 3 is also 0. Only thing is, let's take n is equal to 3, means n at equal to 3. When you place at n equal to 3, its magnitude is also 1, its magnitude is also 1. So how many signals are overlapped? How many signals? Only one signal is overlapped. That is the condition which you can take 1, 2. This is third condition I can take. Y3 of n will be equal to 1, you get. That is when n equal to 3. Okay. So observe here. When n is less than 0, it was 0. When n is equal to 1, if you place at 1, that time also it is equal to 0. At 2, if you are placing it, that also it is 0. When at 1, at 3, that is n equal to 3, that time only one signal was present, which is equal to 1. And similarly, we can change that. Let's place n is greater than 3. Anywhere you can place. Greater than 3. Somewhere here, or I'll place somewhere here. Okay, n point. Where is n point? Here. Okay, n is here. N should be greater than 3. Anywhere on the point. No, I'm not mentioning 4, 5, 6, 7, 8. It is somewhere on the line. So when you place it, it might be somewhere here, right? So somewhere here, if you are placing, so then signal will be present between 3 to n. After 3, if your signals are present also, there is no overlap. Okay, there is no overlap below this 3. Only overlapping is possible. Only overlap is possible between 3 to n. Okay, 3 to n, right? What you can write the equation is, this signal can be present from 3 to n when this is the condition. When is greater than 3, then your signal will be present between the 3 to n, summation of 3 to n, and x of n into h of n. What is the magnitude of x of n and h of n? Observe here. This is h of n minus k. But what is this magnitude? 1. What about this h of n? Its magnitude is also 1. So 1 into 1 is 1. So your signal is present y of n equal to summation of 3 to n into 1. It's of 1. So now we have to write that y2 of n equal to summation of k equal to 3 to n of 1. So this is the arithmetic progression, that if you know this, it is 1 from summation of 1 to n of 1. How we used to write the value? This is n only, right? Arithmetic progression. Summation of, if say suppose k is equal to 1 to n of 1, then we used to write total value will be n only. Okay. Suppose if it is from 0 to n of 1, what used to value? So 1 to n was n. Okay, 1 to n was n. From 0 to n means one more value we have added for this. Okay, so we used to take n plus 1. Suppose signal k is equal to 2 to n. 1 to n was n. Okay, 2 to n means one signal or one element you have subtracted. So answer for this is n minus 1. But signal is starting from 3. 3 to n means how many? 2 signals are you are lessing. So it should be n minus 2. Okay, there should be n minus 2. So therefore, you can write y2 of n y2 of n equal to n minus 2. Finally, you can write y of n which is equal to, right, at 3, n equal to 3, you have got 1. Before that all values were 0. At 3, 1 magnitude. At 4 you have 2 magnitude. At 4 you have 2 magnitude. At 5 you have a 3 magnitude. At 6 you will be having 4 magnitude, and so on. It continues because it is infinite signal, which is okay, discrete one but infinite signal. Okay, so this is about your both the problems. Okay, this is we have discussed about arithmetic. Thank you.